In this video, we're going to do an extension question on the rules of indices. In part A, it says given that y is equal to 2 to the x. In part 1, we need to show that 4 to the x is equal to y squared. And in part 2, we need to express 2 to the x minus 1 in terms of y. Let's start off with the first part. There are lots of different ways that you could show this. What I'm going to do is square both sides of the equation here. So what we'd have is y squared is equal to 2 to the power of x, which we need to square. I'm going to use the rules of indices here. We've got a to the power of m raised to the power of n. We can write this as a to the power of m multiplied by n. In the same way, if we had a to the power of n raised to the power of m, we would have exactly the same, a to the power of m multiplied by n. So what I can do here is write that y squared is equal to 2 squared to the power of x. We know that 2 squared is 4, so we can simply write that y squared will be equal to 4 to the x. That's one of the many different ways that you could show that. So that's the first part. Let's now look at the second part. We need to express 2 to the x minus 1 in terms of y. What I'm going to do is split this up. We've got 2 to the x multiplied by 2 to the power of minus 1. If the bases are the same and we're multiplying, we add the powers. We know that 2 to the minus 1 is 1 half, so we've got 1 half multiplied by 2 to the x. In the first part, we're told that y is equal to 2 to the x, so we can write this as 1 half multiplied by y, or just simply 1 half y. If you like, you could write that as y over 2. In part B, it says by using your answers to part A, or otherwise, find the values of x for which 4 to the x minus 9 lots of 2 to the x minus 1 plus 2 is equal to 0. What I'm going to do is use a substitution. I'm going to say let y be equal to 2 to the x. So using the answers that I found in the first part, I'm going to sub these in. What we're going to have is a quadratic in y. We'll solve for y and then simply make the substitution back to solve for x. So if I've got 4 to the x, I can write that that will be y squared. Minus 9 lots now of 2 to the x minus 1. Here's our expression, and that will be 1 half y. Then we're going to have plus 2, and that's equal to 0. So now we have a quadratic in y. I'm going to multiply through the equation by 2. 2y squared minus 9y plus 4 is equal to 0. This is going to factor. We would have now 2y minus 1 multiplied by y minus 4, and that's equal to 0. So solving for y, we can see that y would be equal to positive 1 half, or y would be equal to 4. So these are our solutions for y. Now, at the start of the question, I said let y be equal to 2 to the x. Therefore, what we can state at this stage now is that 2 to the x is going to be equal to 1 half, or we've got now 2 to the x would be equal to 4. So if we consider now, if this is the case, what we can say from here, 2 to x is equal to 1 half. Therefore, what we're going to have now is x is going to be equal to minus 1. If we look at this one right here, we've got 2 to the x is equal to 4. That's going to give us now that x would be equal to 2. So our two solutions for x are minus 1 and positive 2. So all we've done is use rules of indices, lots of different approaches with this one. We substituted it in, solved a quadratic in y, and then simply gone ahead and solved for x by making the substitution. Final answers, x is equal to minus 1 or x is equal to positive 2.